basics, and second is especially for the chemistry, the advances in the chemistry. So this has been also divided into two sections. A sections having 4 units and B having, that is your review of paper, viva voce examination and presentation. So now I am here to give some materials about the pre-PhD coursework paper 2, unit 2 and 4. Why 2 is combined with 4? So that is in the unit 2 you have already studied by the other teachers, that is synthesis, characterization and properties of the organic materials, heterocyclic materials using spectrometry, spectroscopy, UV, IR, NMR, ESR, etc. But the synthesis was the classical way, traditional way of the synthesis, that is called chemical synthesis. The chemical synthesis which include a number of disadvantages. So I shall teach you about the green synthesis. The green synthesis is the process of the synthesis which should be the safe, non-toxic, non-hazardous, biosafe, economic friendly, and it gives the product but having no byproduct or the byproduct of non-toxic, non-hazardous, harmless. So it is our more and it is most opportunity for us, that is not to only give the material, suggest the way to the technique which must be the cost effective. So just before the green synthesis is nothing out of the 12 principles of the green chemistry, sustainable chemistry. It follows the rules of the green chemistry and aims to create very useful, better and safer chemicals at low cost. The advantage of the technique is marvelous. A number of the advantages of this green synthesis, green approach, green methods, and which is the advantage of the green synthesis, the green processing or the green techniques, green approaches, green method has been shown in the figure shown below. The green synthesis which have the advantage, it must be the eco-friendly, must be the cost-effective, at low cost means cheaper. The simplicity of this technique, how can you handle in very simple way, that is for easier for to handling all the scholars. So it, and other is, that is the high yield. It gives the high yield, maximum product, and our byproduct or the waste during the reaction must be the harmless, non-toxic. It must be the atom economy. So we use the substrate at very low quantity and get the high product. It is safer, having no side effect. It is, that is beneficial for the scholars, the man which is involved in the reactions, or that is also for the environment. And if it becomes in only one step, single step, it will be very better for us. So now I am telling about the what is the 12 principles of the sustainable chemistry, green chemistry. So that is the 12 principles. So some of them are the prevent the waste prevention, economically, the less hazardous synthesis, the less hazardous solvent, and the cheaper solvent, that is reduce the destructive materials, catalyst, which must be the stereochemical during the using, design and degradation of the materials, that is real-time analysis, and the chemistry for the accidental prevent. So these are the 12 principles, and so the process which follows the synthesis, that is called the green synthesis. Some of the examples we may know you about by the following examples, and several examples which you go in the literature or you do survey. So one is the oxidation of the thioether. So now if you go through the oxidation by the classical route, chemical routes, it will gives only 50% product, and it gives, that is much time. But this dialkyl ether, in presence of the catalyst beta cyclodextrin, in presence of the water at room temperature with NBS, that is the N-bromosuccinamide, it gives the, that is sulfoxide, dialkyl sulfoxide, and it gives in only 1 or 2 hours, and this gives the 90% product. Second one is the oxidation of secondary alcohol. So oxidation by the secondary alcohol by chemical route in presence of the chromic oxide H2SO4, it needs reflection at high temperature, but in the aqueous medium at the DBDMH catalyst, and sodium nitroxide in presence of water only at 60 to 80 degree, and in only 30 minutes it gives the ketone having the higher percentage of the yield with respect to its chemical route. So many examples of the Claisen reaction, Perkin reactions, Wheating reactions, or various the reactions, well-known reactions. We only change the solvent and the catalyst we shall get, and the technique, the various other kind of the energy generated source, if you apply, in that case we shall get the maximum product having less toxic and the high useful materials. The safer ways for the synthesis are given below in brief to mention. The bright side of the strategy is, that is the microwave assisted technique. So microwave irradiation by the microwave reactor, this gives the rate of the reactions high, very high, due to thermal gradient effect, high penetration and rapid heating. Other plus point of this process is this is very fast reactions in comparison to the classical reactions, chemical reactions. It takes very less time and it is very simpler way, and the conditions is very mild. Another second technique is the ultrasound assisted technique. The sonication means this ultrasound wave generated reactor, it gives the ultrasound assistance and provides the controlled synthesis of desired product involving green processing via generation of the sound wave, that is the ultrasonic spray pyrolysis and the sonochemistry are the best way to synthesize the green product. Third one is the mild reducing agent based technique. Most common reducing agent such as glucose, the most common reducing agent such as starch, amine, amino acid, tyrosine have been used for synthesis of the nanoparticles by simpler reactions with harmless effluent at very low cost. Aqueous, as you know, the water is the most greener solvent, most significant solvent for the organic synthesis. As you know, for the organic synthesis you use the organic solvent which having very high hazardous effects, but the water have no non-hazardous. It is harmless, cost effective and eco-friendly and having toxic byproduct. So if we process, if you do extend the organic reaction in aqueous medium, we will get that is the product with less toxic byproduct waste, and it will be very cheap for us. So only we have to put our efforts to next point is the magnetic field assisted technique. This is similar with our, that is the ultraviolet or the ultrasound or the microwave assisted technique. Here we use the magnetic field. So there is a numerous advantage of this synthesis due its simplicity to product having high magnetic properties, thin layer composites and involvement of the electrospinning is in the green chemical reactions. Next is the biological method. It includes the plants-based technique, microorganism assisted technique, mycogenetic and the phytogenetic synthesis. It consists of the reactions with the enzymes, the plant leaves, phyto or fungi, bacteria and the secondary metabolite. Next one is the hydrosolvothermal technique. The prime advantage of the hydrothermal method is to get a product in crystalline form. It consists of an autoclave cylinder of thick outer steel wall, consists of a steel wall with protective insert of Teflon, quartz or titanium. Next one is the mechano tribo ball milling chemical synthesis. So it is in this process there is the only work of the mechanical force. So it must be the solvent free, catalyst free, and it is the solid state reaction and proceeded by the mechanical energy via ball milling or the mortar pestle mixing. Numerous solid dispersions of the drugs co-crystals of pharmaceutical active materials, and the organic eutectics and molecular complexes have been synthesized in recent past. Now, that is the technique. Using the suitable catalyst and suitable solvent that may be in itself, that is the green synthesis. If we think about that is a new product through the green synthesis, in that case we have to search a proper suitable catalyst and proper suitable solvent which must follow the rule of the 12 principles of the sustainable chemistry, green chemistry. So these days that must be that coming under that is the green process. These days supercritical green solvent such as supercritical CO2, which is non-toxic, eco-friendly and non-flammable, have been used for the green synthesis and obtaining the desired product. The best solvent after water is considered ionic liquid, which involved a salt ionic compounds formed of ions and its ion short-lived ion pairs, and stays in liquid state at room temperature. It possesses the hydrogen bonding between the molecules within with the van der Waals interaction, and this catalyst, suitable catalyst, that may act as the photocatalyst. So the catalyst free organic synthesis is the standard greener alternative of that is classical reactions. Sometimes using of suitable catalyst reduces the times taken during the reaction, gives the high product, and it is seen having the very low cost. It also gives at the low temperature. The photocatalysis, due to the electronic excitation of the substrate, which is due to the radiation of the UV light, means it is also the example of the UV irradiated assister technique. It gets much reactivity during the electronic excitation and gives the higher yield at shorter time. Now, recently using the green process, a variety of materials using in the water purification, energy generation, electronics, medicine, pesticides have been synthesized. So, dear student, only so you have to know about these processes which have been mentioned here for your research work. The chemical roots have become old today. So if you go through the synthesis in your laboratory, always keep in your mind to extend your research work through and follow the green chemistry, sustainable chemistry. So most of these days the nanoparticles, gold nanoparticles, silver nanoparticles are being synthesized by the green process. So now this is the second our lecture concerned with the second unit of the paper 2 pre-PhD course. Now the extension of this present study with the our unit paper 2 unit 4, that is the synthesis, characterization and properties of nanomaterials. So how can you synthesize nanomaterials in laboratory through the green processing, the green synthesis using the green approaches, method, technique. Thank you.